All right, good evening everybody and welcome to another webinar that we're doing on TCS NQT Ninja. So this is the national qualifier test of TCS for Ninja. My name is Aneeq and I'll be doing another question with you today in this series of ours where we are doing one NQT question every day. So I hope your coding skills are improving as we continue to talk about more and more of these questions. Today we'll look at a question that is a little bit more involved. That is, it's going to be not very straightforward because it involves two concepts, and that concept is both of a Fibonacci number and a prime number. So there are these two concepts that are there in this question that we're going to do. So I'll get to it right now, but just before I start, again just want to ask everybody, please make sure that you subscribe to this channel, because if you subscribe, then you will get the notification of all of the future webinars we're doing. We're going to do a webinar every day till the Ninja Day, where we're going to discuss not only coding questions but also programming MCQs. That's coming up soon, so you don't want to miss out on that. And after NQT, we are again going to start a series on Wipro questions, and then we're again going to start a series on AMCAT questions, and so on. And every campus company that comes to your campus, we are going to do a specific session on that on these webinars. So you don't want to miss out on that. Make sure that you subscribe to this channel and you will get information about all of the videos that we are uploading. So subscribe and do share this video with your friends, because learning alone is never fun. Share it with them, they'll also benefit for the upcoming campus rounds. So welcome everybody. Thanks for being on this webinar, and let's get started on today's topic. Right, so just going to the today's topic. So today's topic is this question called TCS NQT Fibonacci Prime. So that's the topic for today. It's called Fibonacci Prime. And just before I go to the topic, I know there are a lot of newcomers over here. So let me just very quickly guide them through what NQT is. It will hardly take 2 minutes. So this is for all the newcomers over here. So to all of the newcomers, so I just want to say this. The NQT exam does not only have coding questions, but the coding and programming MCQs are the most important questions in NQT, because they account for more than half of the test. So there are about 43 marks last time that were awarded just for programming MCQs and coding. So you want to have both your programming MCQs and your coding both very top notch, very good. Okay, English and quants are also important, and they carry 35 marks, but you know, these are such subjects that probably towards the end, like, you know, last 2-3 days you can practice for, but programming MCQs and coding you will not be able to clear until you practice. And right now is the correct time to start, because the more you delay it, the more difficult it will get for you to remember all of the topics, like remembering the input, remembering the output, and remembering all of those things. It will get difficult for you, so it's better you start now on all of these topics. So specifically for programming MCQs and coding, what should you prepare? Well, there are two things. One is you will actually have to write a code. So in the coding section, you will be given 30 minutes. You can choose any one of these languages. Most of the students choose C because they are most comfortable in that. From their first year, they remember this. But many of you might choose C++, Java, or Python. There is no advantage or disadvantage on anybody on choosing this. One question we have always got is it Python 3 or 2? Which one is it? Well, from our expectation, it should mostly be Python 3, but even then the difference between 3 and 2 is really not much. It's just a print statement. So just in case you suddenly got Python 2 or suddenly you got Python 3, just remember the difference in the print statements, and that should be it. As it is, these are all very logical coding questions that you're going to get. You're not going to get, you know, questions that depend on you using core features of Python. You are going to get questions that are just using a little bit of if else, a little bit of for loops. So you can go ahead and use whichever. I would say practice in 3. I don't think they will be doing 2, but in case, you know, suddenly they ask for you in Python 2, just go ahead and you know, just make sure the print statements are correctly written over there. That's mostly about it. Otherwise, C++, Java, I'm sure, choose the language that you are most comfortable with. Don't try to learn a new language. In programming MCQs, these are the topics that you get. So you get these are very famous MCQs that you're going to get. You're going to get MCQs on increment decrement operators. You're going to get MCQs on C pointers. No matter which language you code on, let's say you are coding in Java where there are no pointers, you're still going to get some MCQs on C pointers, because that's part of your subject, so they're going to ask you that. There's something called order notation, which we will cover in a future webinar. And searching sorting, this is things like binary search, bubble sort, insertion sort, merge sort, selection sort, and so on. So they're going to ask you certain MCQ questions based on this concept. So this is the syllabus for it. For coding questions, they'll ask you questions in these languages, and they're generally, from what I've seen, the past year's questions have been around these topics. They have not been more detailed than this. They have not gone to data structures or anything. So data structures, probably in the interview they might ask you. We One of our candidates just did an interview recently, and they did ask advanced data structures at that time. But in the NQT round, they're not going to ask you all of this as per the last year's pattern. Instead, what they're going to do is focus on maths, conditionals, loops, patterns, arrays. And what we're going to do is, today we are going to see a question that is a mixture of maths and patterns and loops. Basically, it's a series questions, and in series question you need loops, you need to understand patterns also, and you need to have some knowledge of maths. So that's what series questions are about, and today's webinar is going to be about a series question. And that series question is nothing but Fibonacci Prime. That's what it's called. It's called Fibonacci Prime. And let's start understanding what a Fibonacci Prime sequence looks like. So that's what we're going to do right now. And as always, before I start the actual question, number one, if you have any doubts or if you have any clarifications, please post it on the chat. My team is online. The Edyst team is always online actually, and they'd love to hear from you. They'd love to understand where you're going wrong. And towards the end of the session, I'll help you out with those doubts. If at all you are not able to get your doubts right now, if you're not able to clear your doubts right now, make sure you email us at, sorry, this one, that's team@edyst.com. Make sure you email us at team@edyst.com, or you can just WhatsApp us on this given number. And if you WhatsApp us or email us on this number, we will get back to you, or we might cover your question in the next webinar. So these are 2-3 options for you. And just one last reminder, make sure you subscribe to this channel, share it with your friends, because I'm about to start the tutorial for the question called Fibonacci Prime. So what does this question actually talk about? Well, let's open it up on the Edyst platform and read the question as is, and then we'll start distilling or start understanding what the question is talking about. So this is the question on the Edyst platform, right? So it says, consider the given series 1, 2, 1, 3, 2, 5, 3, 7. Now, generally you'll be given a series like this, and you will have to understand how the series is working. Like what will be the nth term of the series? How do you predict the nth term? Luckily, this is not one of those series questions. In this question, they are already giving you what the series is made up of. They're already giving you, what you could say is, what exactly is constituting the series, which is, the series is nothing but a mixture of two other series. All of the odd terms in the series form a Fibonacci series, and all of the even terms are the prime numbers in ascending order. Well, what does that mean? If you look at it over here, let me just zoom in so that you can all see. So if you look at it over here, 1, 1, 2, 3, 5, 8. If you know your Fibonacci series, it forms a Fibonacci series. Similarly, the even numbers are 2, 3, 5, 7, 11, 13. These are nothing but the prime numbers. So basically what they're saying is, let's just distill the question further, and I'll just come back to my slides. So what they're saying is, you are given a series, alright, so you are given a series over here, and that series, their odd terms, so if you take these terms, their odd terms form the Fibonacci series, right? So every alternative term here is the Fibonacci series. So 8 plus 13, we'll actually get 21 over here. So every odd term is the Fibonacci series. So this is the first term, this is the third term, this is the fifth term. So the first term is 1, the second term is the third term is 1 again, then it is 2. 2 is the sum of 1 plus 1. Similarly, 3 is the sum of 2 plus 1. Then after 3, we have 5. So 5 here is the sum of 3 and 2, right? Then we have over here 8, which is the sum of 5 and 3. So if you notice here, what's happening is we are getting on all of the odd terms, in all of the odd terms, we are getting a Fibonacci series. So what about the even terms? The even terms are all forming prime numbers. For example, 2 here is the first prime number, 3 is the second prime number, 5 is the third prime number, 7 is the fourth prime number, 11 is the fifth prime number, 13 is the sixth prime number, and so on. So these are all prime numbers. So if you had to separate these two out, what you will get is the first series is something like 1, 1, 2, 3, 5, 8. So this is the Fibonacci series, and the second series is 2, 3, 5, 7, 11, 13, and so on, which is the prime number series. So this is your prime, and this is your Fibonacci series. And what's happened is after every Fibonacci number they put a prime number. So it's 1, 2, 1, 3, 2, 5, 3, 7. If you look at it, that's how it is over here. 1, 2, 1, 3, 2, 5, 3, 7. That's how it is. So they have combined both the Fibonacci series as well as the prime number series, and combining both of these series, what they've asked us to do is, now the question is not to generate the series. The question is, if I give you, let's say, an n. So let's say I give you n is equal to 1. You have to print 1 because it is the first term in the series. If I give you n is equal to 2, you have to print 2 because it's the second term in the series. If I give you n is equal to 10, then what would you print? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to print 11, which is the 10th term in the series. So we have to print 11 over here. So they're going to give us a certain n, and we have to print the nth term of this series. Okay, and the series, as I said, is a mixture of both the Fibonacci series as well as the prime series. So what in effect we have to do is that you are going to be given an input n. So we have to take only one input, that is input n, and we have to convert that into the nth term of the series. That is, if it's 10, we have to print 11 because the 10th term of the series is 11. Okay, how do we go about doing this? What is the logic that we are going to follow? Well, the question automatically gives us the logic. The problem here is not so much the logic, it is the implementation of the question. So in these kind of questions where the logic is sort of straightforward given to you, it's going to be a very implementation heavy problem. And what do I mean by implementation heavy? It means the code will be more. When the logic is not really clear to you, that time the code will generally be less. So it's not a given formula, but it's a way of knowing in the exam. If you're writing too much code for a very simple question, then you know that you're probably doing it wrong. So if you're given a very, very big question, but with a simple logic, let's say the logic is pretty simple, then the code also is going to be not going to be that difficult, but cracking the logic might be difficult. But in a question like this, where the logic is given, and we have to implement it, so now it's implementation heavy. So just keep that in mind, that if the logic is given, the implementation might be hard. If the logic is not given, in which case you have to find the logic, then mostly the code will be easy because the logic part will be difficult, right? Okay, so now how do we go about solving this question? Well, the hint is half in the question itself. The question says all of the all of the odd numbers, that is the first term, the third term, they all form a Fibonacci series. And if you look at the even terms, they all form a prime series. So what we need to do, if we can just distill this properly, okay, is if we are given an even number, we are supposed to print some prime number, and if we are given an odd number, we are supposed to print some Fibonacci number. For example, if we are given n is equal to 1, so we have n is equal to 1 over here, we have to print some Fibonacci number, as you can see. If we're given n into 2, we have to print some prime number. Now which prime number is it and which Fibonacci number it is, we'll come to know about that in just a bit. But we have, if the n given is odd, we know it is a Fibonacci number, and if the n given is even, then we know it is a prime number. So far so good. Now how do we know which number to print? So let's look at it like this, right? If n is 1, we are going to print a Fibonacci number, which is this one. If n is 2, we are going to print a prime number, which is here. When it's 3, we are going to print the second Fibonacci number. So let's just write it down. We'll print the first Fibonacci number here. If n is equal to 3, we'll print the second Fibonacci number. For n is equal to 2, we are going to print the first prime number. For n is equal to 4, we are going to print the second prime number, right? Because this is how it's going. It starts here. The first number will be the first Fibonacci number. The second number will be the first prime number. The third number will be the second Fibonacci number. Fourth number will be the second prime number. Then let's keep going on. We will see a pattern coming here. N is equal to 5, we print the third Fibonacci. Then n is equal to 6, we print the third prime. So do you see a pattern emerging? Well, it's a pretty simple pattern. Well, the pattern here is, if you have an odd number, we have to print Fibonacci, that we know. And which Fibonacci number should we print? We'll come to that. But for the prime number, it's pretty simple. If it's an even number, we have to print a prime number, and that prime number is nothing but the n by 2th prime number, right? So when n is equal to 2, we print the first prime number. Where n is equal to 4, we print the second prime number. Where n is equal to 6, we print the third prime number. So this seems straightforward. N is equal to 2, first prime number, that is 2 by 2 is 1. N is equal to 4, second prime number, 4 by 2 is 2. N is equal to 6, third prime number, 6 by 2 is 3. So we know which prime number to print. Now, judging by this logic, well, the other one also becomes pretty straightforward. The other one is, if we have an odd number, then if we take the n by 2 plus 1, what do we get? Well, when n is equal to 1, n by 2 plus 1 is equal to 1, right? So that's the first Fibonacci number. When n is equal to 3, n by 2 is 1 plus 1 is 2, which is the second Fibonacci number. When n is equal to 5, 5 divided by 2 is 2, 2 plus 1 is 3, so we print the third Fibonacci number. So whenever we have an even number, we print the n by 2th prime number, and whenever we have an odd number, we print the n by 2 plus 1 Fibonacci number, right? That's what we do. So just recapping over here, if you actually just write it out, you will get n is equal to 1, we want to print the first Fibonacci. N is equal to 2, we want to print the first prime. N equal to 3, second Fibonacci. N equal to 4, second prime. N is equal to 5, third Fibonacci. N is equal to 6, third prime. Now, how do we relate from n to which prime number we should do, or which Fibonacci we should do? Well, first things first, if n is even, then we know for sure that it's a prime number. So that's the first thing you have to do. When n is even, definitely it's going to be a prime number. Which prime number? The n by 2th prime. When n is even, like 2, we print the first prime. So it has to be the first prime number, n by 2th prime. When n is equal to 4, we print the second prime. N is equal to 6, the third prime, and so on. Now, for Fibonacci, we have to print the n by 2 plus 1, which is n over here was 1. 1 by 2 is 0, 0 plus 1 is 1. 3 by 2 is 1, 1 plus 1 is 2. So second Fibonacci number is what we print. So just by looking at this, we have solved a lot of our problems already. We know that we have to print the n by 2th prime, and then we have to print the n by 2 plus 1 Fibonacci number. So if I have to write the pseudocode or the pseudo logic, this is what it would look like. If n is even, find the n by 2th prime number. If n is odd, find the n by 2 plus 1th Fibonacci number, right? Now, here what I am assuming is you've heard of these terms called prime number and Fibonacci number. I hope you've at least heard of them. If you haven't, our warm-up module will really help you. The Edyst pack that we have created, in that the first module is a warm-up module where all of your simple concepts like prime numbers and Fibonacci numbers is going to really be covered over there. So make sure that you have completed the first warm-up module, and it's completely free to do the first warm-up module. So go ahead and at least do the first warm-up module to understand how to do the prime and Fibonacci numbers. What I'm going to do right now is, while this is the pseudocode, we can write more detailed pseudocode, but in the interest of time, I'll go and jump directly into the code of the question. So generally I don't do this. I first write the pseudocode, but because we have a little bit of time constraint, I'm just going to go and write the actual code so that you see how the code is written for this one and how I divide the code into different parts, right? So that's what I'm going to do. And specifically speaking, I'm going to divide the code into functions. So yesterday we were talking a little bit about functions. Let me show you how to use functions in C programming, and in Java, Python also it's pretty similar, but in C programming I'll show you how to do it, and then we'll see how this code can be done. So let's go ahead and actually open up the Edyst platform and try to write the code for this question. So let me do that. Okay, so we have the Edyst platform here, and yeah, all right. Let me just choose the C language. So I've just chosen the C language. Now the first things first that you want to do is you have to write the um, header files, because this should be like a habit to you. Like it's like a habit that in the morning you get up, drink some water, probably brush your teeth. This is the kind of habit that you should make, that these 3 or 4 lines you should write before you start any code, so that you are not stuck in some compilation error because you forgot to write return 0 or you forgot to write int main. You should never be caught in this thing. So this you should have written always completely. Right now, unlike other times, I'm going to write the main method completely towards the end. I'm not going to write the main method right now. Let me first write 2 methods. The first method I'm going to write is called isPrime. This will check if a given number is a prime number or not. This will return an integer. Hence, I started with writing int isPrime. It will return an integer, and what that integer will return, I'll tell you right now. But it takes as input or as parameter a number, which is basically it takes a number as parameter, int num. If it's prime, it's going to so if it is prime, returns 1 if num is prime, otherwise returns 0 if num is not prime. Okay, that is what this specific method does. It will return 1 if num is prime, and it will return 0 if num is not prime. That is what this method is going to do. That's why, because it's returning an integer, it's int, and because it's going to accept an integer as a parameter, it's called num. Okay, it's called int num. Alright, so when is a number a prime number? If the number, so this is the prime number code, and I am assuming you all know what a prime number is. We have discussed exactly how to find a prime number and everything in the warm-up modules, so you can check that out. But meanwhile, what is a prime number? A prime number is a number greater than 1 that is only divisible by itself and 1. Like 2, 3, 5, they have no other factors apart from themselves and 1. That's what a prime number is. So let's write down the conditions of when a number is going to be a prime number. If the prime number is less than or equal to 1, let's say it's negative or something, or if it is 1, then definitely it is not a prime number, so we return 0. Okay, if the number is equal to 2, or if the number equal to 3, or if number equal to 5. I generally like to write this, although you don't need to, but I like to check the first 3 prime numbers because it's just pretty easy to check them. So over here what happens is we're just checking the first 3 prime numbers, and that's it. Let me put it in else if. Okay, now what we're going to do is we're going to check if the number is even or not. Right, if the number is even, there is only one even prime number, and that is 2 itself. That's the only prime number. But we already checked if it's prime or not, and if it's 2, we would have returned 1. If it's not 2 and if it's still an even number, then we know it is not a prime, so we return 0. Right, now these are the major cases that we've covered. The other cases are, we have to check from 3 up until that number. We basically have to check if that given number has any factors or not. If that number has factors, then it's definitely not a prime, otherwise it's a prime. So what we're going to do is we'll run a for loop, right, and I'll start from 3 because it's not a prime number, so it's not an even number, so there's no point in starting from 2. So I'm going to start from 3. Let me check all the way up to num divided by 2, and I'll explain num divided by 2 at the end. If somebody has a doubt, I'll explain that, but I'll go up till num divided by 2. Now if any of these numbers from I up till number divided by 2, what am I doing here? Let's say I have the number 11. What I'm doing is from 3 up until 5, I want to check if there are any numbers that divide 11. Why am I checking only up till 5? And why do I check only up to num divided by 2? The reason I'm checking up till num divided by 2 is, for no number will you get a factor greater than num divided by 2. Just think about it. What is the greatest factor of 20? You get 10 into 2, but you will never get 11 into something, 12 into something, 13 into something. If you check up until 10, you are done. You don't need to check any more factors. So similarly, I am checking only up to num divided by 2, and I'll start from 3 because I already checked for 2 over here and it's not even. So I'm going to check if num mod I, which is nothing but if number can be divided by the given I, then it's definitely not a prime, so we return 0. If throughout this loop it never found a factor and it did not return 0, that means it is a prime and we're going to return 1. Right? So I've very quickly explained this. Prime number takes a little more time to explain, but just look at these conditions one by one. Yesterday we were discussing, or actually on the first webinar we were discussing how the if else if checks each of the characters or each of the conditions one by one. So if let's say the number is less than equal to 1, we return false. If the number is one of the first 3 prime numbers, we return false. If the number is even, then we return false. Otherwise we check if it has any other factors. If it has a factor, then we return false. Otherwise we return true. So this is the code for is prime. Now let's write a code to generate the nth prime number. So we're going to write int Fibonacci int n, which what does it do? It does nothing but returns the nth Fibonacci number. Okay, that's what it's going to do. Now if you remember your Fibonacci code, this is how it looks. The first number given to us is 1 because that's the first Fibonacci that is given to us. If you can see, that's the first Fibonacci. So we have int first is equal to 1, int second is also equal to 1. Then the next number is nothing but first plus second, right? So let's leave it at that. Now if n equal to 1, that is it, they want the first number, then we just return first. If n equal to 2, we return the second number. So far so good. Now if it's neither n equal to 1 nor n equal to 2, that means it's a number greater than that, right? So else we have a number greater than 2. How do we check that out? We will use a for loop. So for I equals to, now we're starting from the third number. So int I equals to 3, I less than equal to the given n, I plus plus, sum is equal to first plus second, second is equal to, first is equal to second, second is equal to sum. Now this might look very confusing to you. Why? What actually happened over here? And what I'd suggest is you go ahead and check our tutorial for the Fibonacci series. Right now just trust me that this will return the nth Fibonacci number for you. If you didn't understand it completely, just go ahead and check our tutorial on Fibonacci. You'll understand what this magic over here is happening. Some of you might already understand what's happening over here. In that case, great. For those of you who don't, make sure you just check out the tutorial that we have for Fibonacci and you'll understand this one. If you didn't understand, just wait and understand that all this function does is takes n and returns the nth Fibonacci. So at the end of this, we will return sum, right? So that is the nth Fibonacci number. So far I have not written even a single line of the main method, but what I've written is two methods. One method that finds out if a given number is prime or not, and the second method that takes an n and returns the nth Fibonacci number. Now let's actually start writing the main method, and in that we're going to get an input. This input is going to be an integer. So let's not write int input, let's write int n. That's the given integer. So we have scanf mod d and n. So we took input the integer. Now what did we discuss? Let's just go back to our pseudocode. What did we discuss about what are we supposed to do in all of these times? If n is even, we have to find the n by 2th prime number. So let's start with that. If n is even, we have to find the n by 2th prime number. Okay. All right. So if n mod 2 equal to 0, that means it's even. What we have to do is we have to find the n by 2th prime number. So we have to find the n by 2th prime number. How do we go about doing this? Right. Let's create a variable called int answer. This will store our answer. No matter if n is even or n is odd, it's going to store our answer. So we have to count the number of primes and we have to get the n by 2th prime, right? So let's count the number of primes in this. So far we have 0 primes, and let's count, let the counter equal to 1 over here. Okay. All right. So now what we're going to do is we're going to check while number of primes is not equal to n by 2, because we want to find the n by 2th prime. We want to find the n by 2th prime number. So if we want to find the n by 2th prime number, we'll keep checking till the number of primes is not equal to n by 2. Okay, so till it's not equal to n by 2, we're going to increment counter. Okay, and what are we going to do? We are going to check if the given counter over here is prime or not. And how will we check that? We will check that using the function that we created above. So if is prime counter equal to 1, that means that the given counter is a prime number. If it is a prime number, then we increment our number of primes. So that means our number of primes has increased. Can you notice over here the beauty of not writing the prime number code in the main method? If we would have written the prime number code in the main method, it will become very ugly to watch here, and we would not be able to debug what's the problem. Let's say our prime numbers is buggy. We can actually just go to the prime number code and fix it. This is the prime number code. We'll be able to fix it and come back. But if we are just over here and we make some mistake, it will be very difficult to figure out whether the mistake was with this while loop or with this if condition. We don't know. So anyway, just coming back, what we're going to do is, just to tell you the logic, what we're going to do is we're going to count all of the numbers from 1, and we will keep increasing our count till we get the n by 2th prime number. How will we know if we get the n by 2th prime number? The number of primes is going to keep a count of how many prime numbers we have come across. Currently, we have come across 0 prime numbers. This counter starts from 1. It will become 2 over here. This function will check if the given counter is a prime number or not. If it is a prime number, we increase the number of primes we have found so far. If we find the exact number of primes we needed, then great. It's not going to repeat again, right? And we just need to, that's it. So we increase the counter, we check if we've hit the number of primes. If we've got the number of primes, then we know that the last value of the counter was our answer, right? That was the n by 2th prime number, right? So that's what we come to know, all right? Otherwise, what do I mean by otherwise? This is the condition. What is the condition? If n mod 2 equal to 0, that is the given number is an even number or not. If it's not an even number, then what do we need to do? We need to print the n by 2 plus 1th Fibonacci number. Just to remind you all, let me just go back to the slide. If n is even, we want to find the n by 2th prime number, which we just did. If n is odd, we want to find the n by 2 plus 1th Fibonacci number. That's what we want to do. Okay, so just going back, n by 2 plus 1th Fibonacci number. Now the good part is the function that we had written returns the nth Fibonacci number. So we just need to pass the correct n, and then we got our answer. So answer is equal to Fibonacci n by 2 plus 1, right? That's what it is. Let's just put the brackets more carefully so that we know that we're in the correct thing. All right, now we have this. Now we got the answer either from here or from here. Either the here will give us the answer or here will give us the answer. In both cases, we just need to print the answer. It's an integer, so printf mod d. Let's print a new line after that, and we print answer. Okay, all right. So let's just run the code and see if it's running or not, and then I'll do a summary for this. So let's just check if the code is running. Did we make any compilation errors? Okay, there were no compilation errors. It ran perfectly. That's great. And let's submit it and see whether it's working or not. Okay, great. So it passed all the test cases. So let me just summarize the approach that we have done over here. First of all, do not expect that you will be able to just write it in one go and completely be able to solve it. That's not how it works. It is generally difficult to get it on your first try, but what is important is just as how I've written it over here in terms of if n is even, we do this, if n is odd, we do this. That is what you need to do. Divide your code or divide your logic into different if else statements and do the actual logic, right? If you don't divide it like this, if you don't write down your logic before you start your question, you are going to get into trouble because you will start implementing all sorts of different things. The second thing that we did apart from dividing it like this is the use of functions, or some might even call it methods, right? So we used a method or a function to make our life easy. The reason why we did that is, let's say there is some problem with prime numbers, right? Let's say there is some problem with prime numbers. We know exactly that we have to go to the prime numbers method and then look at why it's not working. And if there's a problem with Fibonacci, then we'll just go to the Fibonacci numbers and see why it's not working. So just going back to the code, let's see what's exactly happening in the code. So I'll just go back to the code and let's do a very brief summary. What we are doing here is, we are first, this is the main method, this is where the program will start. Even though we wrote all of these methods, the place where the program is going to start is this main method. In the main method, we are taking the input first, we are going to store that in some answer. Now if the given number is even, then we know we have to print the n by 2th prime number. So that is what this code is doing. We'll go into it in just about a minute. But this code is finding the n by 2th prime number. If the number is odd, that means we want to find the n by 2 plus 1 Fibonacci number. Let's look at the Fibonacci series code first, and then we'll come to the prime numbers code. The Fibonacci series code is pretty straightforward. If you've not seen a Fibonacci series before and you don't know how to actually code a Fibonacci series, just log on to edyst.com, check out our basic tutorial on how to find the Fibonacci series. It's very, very basic, and I'm sure you will also be able to solve it. Just go and check the warm-up material and I'll show you where it is. But check the warm-up material and do the Fibonacci series part, right? So this code we wrote for the Fibonacci series. Otherwise, if it was even, then we need to find the n by 2th prime number. Now, the code that we had written for prime over here, this is the code that we had written for prime. This code is there to find out if a number is prime number or not. So it returns 1 if a number is prime. It will return 0 if it is not prime. It does not return the nth Fibonacci number. We have to find the nth Fibonacci number. For prime number, we checked if the number is less than or equal to 1. Otherwise, if it's one of the first 3 prime numbers, we return true. Otherwise, if it's an even number, we return false. Else, we find out if it has any other factors apart from 1 and itself. Then we checked out, so just going back to the prime numbers code, we first assumed that there are 0 prime numbers. We took the first number to check to be 1. Then what we did was we kept increasing the counter, that is, we kept increasing the numbers and seeing did we get the n by 2th prime number or not. If we didn't, we will just increase the counter and we'll check again, did we get the n by 2th prime number. If we got it, we'll increment number of primes. The moment when number of primes is equal to n by 2, it will break and your answer is equal to the last value of the counter. What I'd suggest is, like, I have divided the code into 2 parts. It could be divided further into 3 or 4 parts. So I would suggest you go over this code again and again and understand why we have broken down the code into different parts like this and what's happening in every part. The best way to debug and the best way to understand any question on loops and any questions on series is actually write the values of all of the numbers, which I did in the previous webinar. So please check out the previous webinar. Like, for example, when we are here, at first number of primes is equal to 0. Is 0 equal to, let's say n was 10, 0 not equal to 5? True. Then we'll do counter plus plus. So counter value is 2 now. If counter value is 2, is prime counter equal to 1? Yes. Number of primes equals to 1. It gets incremented to 1. So now maintain the value of each of these numbers, or each of these variables in your notebook, and that's how you should actually debug your question. So finally I ran it and then it submitted. So that's how this question worked. What are the action points to you? So just bringing back to the slides, if you found this question to be helpful and or if you figured out that, oh my god, there are so many concepts that I didn't know. For example, both the prime number concept and the Fibonacci concept are very basic concepts which you should know for your TCS Ninja and your NQT. If you don't know the prime number and Fibonacci concept, you should stop practicing whatever you're practicing and come to the Edyst platform and start practicing for coding. Because see, your aptitude, your cons, that will keep happening. But if you don't know how to find the prime number or the Fibonacci number, this is the most basic question you're going to get in TCS NQT. So make sure that you know at least prime numbers and Fibonacci numbers and you know loops, right? So The action point for you is make sure that you log on onto bit.ly/edist_ccp at the earliest, right? This will take you to the actual course page where we have divided all of the topics required for NQT as well as other campus rounds into very, very specific topics. So I'll just show that to you. So for example, for each of the company we have divided them into different topics. So for example, you have a simple warm-up. These warm-ups are especially useful for anybody who has not coded very recently, or you do just remember your first year C++. The warm-up 1 and warm-up 2 are for that. Then the TCS previous year's questions are there, so your Ninja NQT coding questions are there. We're going to add the programming MCQs also. Then similarly for all the other companies like Wipro, AMCAT, Mindtree, all of them, they are there. And for each one of them, we've divided them into topics. So like for example, AMCAT, there is maths, loops and patterns, arrays, strings. These are the most important topics of what you can do for AMCAT. Similarly for Wipro, there is loops and patterns, maths, arrays, strings, sorting. Again, all of these are very, very important for Wipro, and we've divided all of the questions into those topics so that you can actually do them in a fun way, right? So that's mostly it from what you should do. You should go back bit.ly/edist_ccp, sign up for the free course, the free module for so in the given course there's a free module. So please make sure that you sign up for that and experience the first warm-up section, because many of you do not have the experience for the coding yet. It's only a few days left for NQT. Make sure you do that coding part. Then the second part is go and brush up your skills in any one of your language. So that entire warm-up thing is done, can be done in C, C++, Java or Python. Choose any of your language that you're comfortable in. Don't learn a new language. Choose the language you're most comfortable in and do the questions in that. Okay, so that's the action steps for you. I hope you understood the question. If you didn't understand the question, you can always ask a question right now. So I'll be just checking with my team what are the questions, doubts you had. Or you can if you're not able to understand right now, you do not want to type right now, make sure that in the given WhatsApp number and the given email, please make sure that you send out your doubts to us, and we'll be more than happy to help you in that doubt. So let's just look at some of the questions that we have, and yes, please tell me what are the doubts and questions we have.
On which topics we need to focus for advanced questions in NQT? Are there any advanced questions?
So, are there any advanced questions in NQT, and which topics do we need to focus? Well, the most advanced question that I have seen in NQT is to do with arrays, like finding the most distinct element in an array, or just doing some array manipulation. I have not seen more advanced than that. It's definitely nowhere close as advanced to code beta at all. So you don't need to study things like backtracking, recursion. I have not seen any of those questions come previously. In fact, I have not even seen a data structures question come. The most difficult question seems to be from 1D arrays, not even 2D arrays. We have not seen any questions yet from even 2D arrays right now. So as I mentioned in the slides earlier, if you had practiced from these few topics, I think most of your preparation is done, unless they decide to suddenly change the pattern. There was no question that came out of these things. Maybe you could say a little bit of strings is there, but again, if you know arrays, then strings is also pretty simple for you. So none of the questions were outside these topics.
So is there any way to overcome the time exceeding constraint in NQT?
So in NQT, is there a way to overcome the time exceeding constraint? Well, there are two reasons why you will get a time exceeding limit. So time limit exceeded comes for two reasons. One of the reasons is a silly mistake from your side might cause an infinite loop. Like for example, over here in the code that we had written, if we had written for I equal to 0, I greater than equal to 0, I minus minus, that will keep on going decreasing, and it will never stop. In that case, you will get a time limit exceeded, and it is not at all a problem of efficiency or anything. It's completely a problem of your logic that you missed out on that, and it's going into infinite loop. Whenever you get a time limit exceeded, instead of trying to make your code more efficient, the first 1 minute try to check if you're going to an infinite loop or not. And you will think that, hey, this is a very simple approach, but don't think that. Many students daily on Edyst platform, I see many students go into an infinite loop, and that is causing time limit exceeded, not their logic. Now, having said that, there are some things you need to know to make sure that you don't go into time limit exceeded. For example, in the code that we had just done, and I'm just pulling that code up right now. In the code that we had just done, if you noticed, and I hope you remember, um, one thing that we did, that num mod 2 equal, so we were, what we were doing was, we were started from I equal to 3. This is for finding the prime number, I equal to 3, and we went by num divided by 2. In fact, you can reduce this even further by doing I into I, that is I square is less than equal to n. And for this one, you really need to go and read the Edyst tutorial to understand what I did here. But yes, even this works, and this is even lesser time than your n by 2. So what we had earlier was this n by 2. This also works, and this is what we did. Now these kind of things for prime number you need to know. What many students do is they don't go to n by 2, they go to n, that is they go to num. If you do that, then what you're going to do is you're going to miss out, or you're going to go into extra repetitions that will cause your time limit to get exceeded. So these kind of things that are known to almost everybody, like there is one thing in prime number, there's another one in how do you find the exponents. You don't, if you take too much time to find these things, then you'll get a time limit exceeded. Otherwise, I don't think any of the questions that we have seen are heavy on finding the right approach, that is the most efficient approach. All they care about is finding the correct logic, not really the correct approach to the problem. When I say correct approach, I mean that they are not really asking you to find the most efficient logic. Even a correct logic which is not efficient will be fine.
So how to take an input, whether by using command line arguments or scanf functions?
Okay, a very good question. So, how do we take inputs? Like, should we use command line arguments or should we do scanf? Well, from from our information, what we have got is, I don't think this year they're going to do any command line arguments. So, if you want to do command line arguments, you can do that. But all of the inputs will be in the form of std in. That is, you have to do scanf only. So that's the information we got. And as we had seen the previous year's questions also, there were one or two command line arguments, but most of them were standard input and scanf. So if you're comfortable in C, scanf, if the other languages have their own formats of doing it, but this year I don't think there should be any command line arguments as such.
Can you please tell me logic of contagious array? So
Okay, so can you please tell us the logic of the
sub-contagious array.
sub-contagious array? Somebody wants to know the logic of the sub-contagious array. I think you are either referring to a code beta question or you're referring to a very specific problem. If it is a big problem, then I think better than solving it here, just write down onto this email. So make sure that you just ping us on this email, or write the question on WhatsApp, and we'll get back to you with the solution. Or the best way to get to me, the easiest way to find out and get in touch with me is log on to the Edyst platform. I'm online most of the time. Just ping me at that point and we can chat at that point. So just go to edyst.com, sign up for the complete coding test preparation pack, and I'll be there online, and you can just reach out to me. And if I'm not available, there are other mentors available also. They'll be more than happy to help you with the problem that you have.
So does your interview preparation pack allows multiple user over one subscription?
So does your interview preparation pack allow multiple users on one subscription? No, unfortunately it does not. Basically, if you sign in at the end of the pack, we give out certificates. So we will give out the certificate to the person who has signed up. We don't allow more than one person on the same pack.
So can we store all the Fibonacci up to 1000 in a list and prime numbers up to 1000 and access from the list?
Okay, so Hemant asks a very good question. Like in all of the questions that we did right now, what we did was we would at every time generate the nth Fibonacci number and or the nth prime number. But what Hemant is asking is, can we store all of the numbers? Like let's take the first 1000 Fibonacci numbers and store them, and let's take the 1000 prime numbers and store them. It's a good approach, but that kind of approach you should do only in the condition that you are having multiple test cases. For example, here we have to take just one input and print the nth Fibonacci or the nth prime number. So there is no use in generating thousands and thousands of Fibonacci or prime numbers. However, if the question was like there will be up to 100 inputs, and for each of those inputs you have to find the nth term of the series. In that case, we don't want to generate the n Fibonacci or n prime numbers every time. In that case, we can keep the numbers generated beforehand. So look at the question first, see what it's asking. In this case, it was just asking find the nth term of the series. In that case, we don't need to keep this generated. However, if we are going to continuously need to find the nth Fibonacci or the nth prime number, then keeping these numbers generated will be good. The second thing to remember is how big do you want to keep that array. So 1000 is fine, but always look at the question constraint. If the question says that the n can go up to 10,000, then you will have to generate up to 10,000. Again, Fibonacci numbers grow very, very quickly, so I don't think they're going to do that. But 1000 should be fine, but please just check the question before you do that.
How to take a string with length n as taking n as input?
How to take a string with length n as taking n as input, some integer. I didn't quite understand the question, Karthik, but anything you want to do with input and output, I suggest that you just log on to the Edyst platform. I'll actually show you where it is. So when you log on to the Edyst platform, there is something called warm up one. In the warm up one, if you go to the taking input part, yeah, so if you warm up one, if you go to the taking input part, this taking input and printing output pretty much covers everything. So there is like integer in all of the four languages, decimal in all of the four languages, characters in all of the four languages, and also strings in all of the four languages. So I think it covers most of your test cases, whichever you want, or how you can input and output. If you had a very specific doubt, just come online and chat with me about that, on what your doubt exactly was regarding input output. Otherwise, this is freely available. This first module is freely available. So just go online, practice the first module, and you will be able to take the input like the one you want. Right? Okay. Anybody else?
Nothing.
Okay. So Ramana Misla is asking, can we expect dynamic programming question in TCS Ninja? No, I don't think you should expect dynamic programming. That's a very advanced concept, which generally TCS Ninja will not ask you that. Maybe, just maybe TCS Digital, but I don't think at this stage anybody is going to ask you dynamic programming. I would rather focus on all of the basics and not go for dynamic programming right now.
Python 2.7.
Yeah, so there was a confusion people had with whether we can use Python 3 or Python 2.7, and as I discussed earlier in the webinar, that you can use so from what we know, it should probably be Python 3 only, but just in case they give you Python 2, there's only a difference between a print function for most of the questions you want to do. There are more differences, but most of the questions that we want to do right now, the only difference is generally the print statement. So just keep that in mind and go ahead. And I think it's mostly going to be Python 3, because in CodeVita also, as far as I remember, it was Python 3. So I don't think they'll, for NQT, they're going to use Python 2.7. But still, just remember the difference and go ahead with that. Right? And yep, I think okay, so we've come to a close for this session. Thanks everybody for staying till the end. Thank you all for the questions. That's really it tells us that you're engaged. It tells us that you are watching the video, and we are doing this for you. We love to help you out in all of these campus rounds. We're going to be doing this series again and again, so mark your calendars for the next few days. Every day we're going to be doing a webinar. To get notified on when we're going to do the next one, it will be the same time, but just to get the notification, make sure that you're subscribed to this channel, and if you subscribe, you will get the notification. Also, going forward, in after about 2-3 days, where we cover some of more questions, we will start launching polls so that you can tell us which program you want us to do, and we'll be solving that in the next video after that. So we will be doing some polls. So you will get the poll only if you subscribe to this channel. Make sure you subscribe. Also share with your friends. Don't learn alone. Help each other in cracking all of the questions in the campus rounds, not only in TCS, NQT, but all of the companies that are going to come to your campus. So wishing everybody all the best, and see you tomorrow for another question from TCS Ninja NQT. All the best everybody, and happy coding.